Welcome to another Mathnificent conversation. Today's featured guest we're still on the factoring series, but we're going to talk about a difference of two squares. I cannot stress the importance of being able to recognize a difference of two squares in whatever level math course you're in, starting with algebra and moving up. Difference of squares is one of those topics that never goes away and always comes up. So you want to be fluent with difference of two squares. So I'm going to take it slow in the beginning, but remember, you want to be at a point where you see it, recognize it, and quickly can factor into a difference of two squares. Let's break down a difference of two squares. So for starters, difference means subtraction. So you see we have a subtraction sign. That's where difference comes in. So this only works, you can only factor two squares when it's subtraction. Two squares means our first term is a perfect square. And our second term is a perfect square. Hence, a difference of two perfect squares. So let's take a look at an example. Let's say we want to factor x squared minus 9. So when you first start off with the difference of two squares, you want to see what the actual things are that you're squaring, and then you should become more fluent and just be able to factor without taking this additional step I'm going to take. So I have x, and that's being squared, minus, how do I get 9? That's 3 squared. So if I'm looking at my formula, a is x and b is 3. So that means x squared minus 9 will factor to x minus 3 times x plus 3. Before we take a look at our next example, on the left-hand side, I've listed out the first 21 perfect squares. Now, the ones that are in blue are ones that do not come up very often. It's not often that you're going to see them. The ones that are in turquoise are ones that are fair game most of the time as you're learning and factoring. So if you have not memorized them, because again, being able to notice it is the most important thing. If you don't know which numbers are perfect squares, factoring a difference of two perfect squares is going to be very difficult. You have to be able to look at a number and see that it's a perfect square. If I'm factoring x squared minus 169, again, I see it's a binomial. So that's the first thing that should trigger that it's a difference of two squares. And I see that my first term is a perfect square. So I'm always going to be on alert that this could potentially be a difference of two squares. I know 169 is 13 squared. I'm going to rewrite it as x squared minus 13 squared. So now I know A is x and B is 13. So x squared minus 169 factors into x minus 13 times x plus 13. Okay, now we want to factor x squared minus 121. Again, I see a binomial, and if you don't know, binomial just means we have two terms. The first term is a perfect square because x squared is a perfect square. The second term I know is a perfect square. I know it's 11 squared. So I'm going to rewrite. We have x squared minus 11 squared. So that tells me that A is equal to x and B is equal to 11. So x squared minus 121 is going to factor to x minus 11, x plus 11. Now we're going to step up the problems just a bit. We're still working with a difference of two squares, but now a GCF is required to factor out first. So now I'm asked to factor 5x squared minus 5. Again, binomial, I have two terms, but I notice both of my terms have a common factor of 5. So I'm going to go ahead and factor out a 5. 5 divided by 5 is 1, and 1 times x squared is x squared, minus 5 divided by 5 is 1. So now that I've factored out my GCF, I'm left with a difference of two squares. I'm going to help by rewriting. This is x squared minus 1 squared. 1 is one of the perfect squares that people often forget about, it being a perfect square, but please keep in mind that 1 is 1 times 1, so it's a perfect square. So that means x squared minus 1 will factor into x minus 1 times x plus 1. So 5x squared minus 5 factors into 5 times x minus 1 times x plus 1. Okay, we want to factor 4x cubed minus 64x. So I see both of my terms, so term and term, have common factors of 4 and x. So my GCF is going to be 4x because both 4 and 64 are divisible by 4, and both x cubed and x are divisible by x. So we're going to factor out 4x. 4x cubed divided by 4x is x squared minus 64x divided by 4x is 16. Now that I've divided out my GCF, I'm left with x squared minus 16, which I recognize as a difference of two squares. X squared and 16 is equivalent to 4 squared. So x squared minus 16 factors into x minus 4, x plus 4. So my original expression, 4x cubed minus 64x, is going to factor into 4x times x minus 4 times x plus 4.